In this lesson, we'll be going over some additional teaching strategies that might be helpful for synthesizing ideas as an important tool for generating novel concepts. As the author Zora Neale Hurston said, research is formalized curiosity. It is poking and prying with a purpose. No matter what field of study or discipline, we are all trying to engage our students in some form of research, whether conducting a literature review for a term paper, doing interviews or observational research for a design project. The way that we structure the research process for our students is critical to how they continue to practice it moving forward. But this gathering of information can also be overwhelming and confusing, leaving students feeling like they don't know where to start in creating their own novel interpretations, or to interpret their findings in a way that is both creative and logical. So a critical part of our teaching is to help them apply systems to this interpretation and to investigate systematically and truly all that comes under observation. One strategy that might be helpful for illuminating and connecting big ideas is creating a synthesis matrix. A synthesis matrix is a chart that allows a researcher to sort and categorize the different arguments presented on an issue, which is especially helpful for evidence-based writing assignments like literature reviews. But it can also be helpful for other types of processes where isolating and connecting problems or ideas is fundamental. We'll go through a few different types on the next few slides. In creating a synthesis matrix for a literature review, for example, main sources are listed across the top with specific topics or subtopics along the side. The sources can be abbreviated, as in this example, or you can use it to practice full citation formatting. In each entry, a summary is included first with specific quotes and relevant details, along with the corresponding page numbers. Synthesis matrices can be used with text that students have assembled as part of a research project or paper in a more advanced classes, or with text the instructor has supplied for more introductory levels. Color coding within the synthesis matrix can be a useful tool to help elicit critical reading and writing. In this example, looking at stereotypes, the yellow equal negative connotations, turquoise was used for oxymoronic feelings against logic, and magenta to highlight where authors might use suggestive words related to stereotypes such as groups or we. They can also be good as a tool for highlighting main arguments and points, to eliminate sources that might not be as relevant as originally thought, or to identify gaps in knowledge where new research might be fruitful. Synthesis matrices can be incredibly useful in many disciplines because they synthesize background information to write introductions to research papers, identify possible research questions by visualizing gaps in knowledge, and cite key papers and conclusions to show how new findings support or refute previous work. If we look at a typical formal assignment, the synthesis matrix might lie right in the middle as a bridge between background information gathering and the development of initial draft or idea. Similar in structure to the synthesis matrix, morphological matrices use similar principles to encourage idea generation and analysis. Morphological matrices are particularly appropriate when there is a complex problem with multiple dimensions, approaches, or solutions. The idea of morphological analysis was first introduced by the astrophysicist Fritz Zwicky to uncover, quote, all of the possible solutions to a given problem or current understanding by first deconstructing all possible elements of it. There are three important aspects of the morphological matrix. The first is to deconstruct the important features of the problem that is being addressed. In this example, the first column breaks apart the components of a life vest that are vital to its function and safety. Step two is to generate a range of ideas relating to each of those components. In this case, columns 2, 3, and 4 isolate and explore different ways to design that particular component. And the third is to combine individual elements into a single final series of more comprehensive ideas, evidenced here by the red circles. Weber and Condor, the authors of the paper exploring this particular example, found that 4,782,969 concepts could be generated with this particular approach. Morphological matrices are particularly useful when they combine or juxtapose two aspects of a problem or idea, such as goals and tasks, functions and characteristics, strategies and tactics, and hypotheses and experiments. The example here shows how different user goals or priorities for a wallet design are juxtaposed against formal or aesthetic qualities. As a pure brainstorming tool, the matrix can be incorporated more simply to encourage iterations and evolutions of initial ideas. As the economist John Maynard Keynes once noted, the difficulty lies not so much in developing new ideas as in escaping from old ones. And in different but equally relevant ways, both the synthesis matrix and the morphological matrix are especially effective in helping students make new connections between different pieces of information and generating unique ideas as a result. While these strategies are still fresh in your mind, reflect and record how you might incorporate one or more of them. Consider one for generating ideas and one for synthesizing them. Would they be connected or part of two separate topics or assignments?